Okay, so this is my fourth presentation in 24 hours, and I've been up since 3:30 this morning, so I'm going to sit down this time. Date and time. The more you look at it, the more intricate, horrible things you find. The more you look at that picture, the more intricate and lovely things you find. It's just the nature of date and time. It's a more complicated domain than you might think at first glance. So in Java 8, we've added a new date and time API. When I say we, I guess I wrote a lot of it, probably the majority of it, based on Joda-Time, principles of Joda-Time. Obviously, the Oracle guys helped with some of the integration, some of the thoughts around it. But long term, the goal is that Joda-Time will slowly die away. Hasn't started dying away yet, but at some point it will. There won't be any new enhancements in Joda-Time. If an odd bug needs fixing, then I'm sure it will. So the goal is to replace java.util.Date, java.util.Calendar, time zone, and date format. Now, will these things be deprecated? Well, in the Java 9 JEP for deprecation, it actually does list java.util.Date as to be deprecated, but there's been no sign of that actually happening yet. So I'll try nobbling them next week at Java 1 and see whether they're seriously considering it or not. We will see. So it is a new API. So it's not Joda-Time put into the JDK. It's a new API based on the principles of Joda-Time, inspired by it. It did take many years to do, drove me mad, but I'm mad anyway, so no big change there. So it was started off as an open source project. So it started off on java.net, then migrated to SourceForge, then migrated to GitHub. So yeah, it went through quite a lot of change over time. There's still some documentation available on 310.github.io. The original code was BSD licensed. When it went into the OpenJDK, it became GPL licensed, as the rest of the JDK is. If you actually look at the classes at the top, you'll see that the header includes the original BSD license. But they're not BSD licensed. It's just a copy of the original header. Lots of tests to keep everything happy. And if you want to use the same API on Java 6 or 7, you can do. Most of the time, you'll want to use Joda-Time on Java 6 and 7. But if you're in the process of migrating to 8, you might find it useful to use the backport. So yeah, we're trying to make a comprehensive model in code for date and time, supporting all those commonly used global calendars. Now, Oracle decided what were commonly used global calendars. I didn't. It's immutable, so it's going to work well with all the lambda and functional stuff, allows them to potentially be value types if we ever get that in Java 10 or 11. They should be type safe. So we should actually be able to say, this object represents a date, and be able to pass that around and know it's a date and know what it contains. We want to avoid primitives where that's sensible, make sure it's IDE friendly, documenting, and that we consider all the various things we have to integrate with. That's the Greenwich Observatory in London. If you ever go on a holiday to London, I think Greenwich is one of the nice places to go and visit. So date and time, it drives our lives, and obviously people have thought about dates and times for thousands of years, which as a result means that these words have many different meanings. So part of what Joda-Time did, and part of what the date and time API does, is to kind of define what is a consistent language for this domain in terms of computers. You need that consistent language to be able to communicate. So it follows the principle of immutability. We want things to be fluent, so we can read the code like a sentence, and it just makes sense. Methods should be nice and simple, clear, explicit, and expected. If the Java doc is too complicated, the method is probably too complicated, and maybe the concepts need splitting. And I wanted it to be extensible, because I don't want to be going back and adding stuff to the JDK over time. It's far too slow to be able to add stuff to. You need to be able to add stuff to it outside the JDK. A pretty French date thing. So fundamentally, days are defined by the sun, and they're intended to count the track of the seasons. That's why we count them. So a calendar system is the thing that defines the counting system, and there are, of course, multiple different counting systems by which you could count days, months, and years. So the date is the label for the day. And it so happens that over time the world has decided that the ISO calendar system is the default one that it tends to use across the whole world. Now, we might refer to this as the Gregorian calendar system, the one that came out of the Vatican. However, if we can sidestep religion by calling it the ISO one, that seems good to me. So we have a class called local date. That means we can actually represent a date without any concept of time and without any concept of time zone. So it is just the year, month, and day. It does not represent the date in the local time zone. It represents the date in no time zone. So that is what you need if you want to represent a birth date, the start and end date of a trade, a holiday, and lots of other similar stuff. So we can simply create one. Localdate.now will create one, and that will use the default time zone of your machine to create it. We can create it using 2013 September 12, so it's nice and obvious what we're creating. You can use 9 instead of September, so months go from 1 to 12, not from 0 to 11. That's nice, isn't it? Nice convenient methods. We can say if date 1 is after date 2. The toString is a nice format. If you've ever seen the toString of a Gregorian calendar, you'll know what a not nice format is. And we can ask, is it a leap year? What's the length of the month? So it has all the nice methods we'd like to have on a date object. We can add to it date plus months minus days. We can set the day of the month. We can set the month. We can nicely set the month to a meaningful constant, just with month.october. What does plus months mean? It means effectively what is the standard definition in most date and time libraries for plus months. So if you're on the 1st of January and you add 3 months, you'll go to the 1st of April. Exactly. If you're on the 31st of January and you add 1 month, then there is no 31st of February, so it will go to the last valid day of February. Okay, and that's the of that year, yeah, and that's the standard definition you'll see in most date and time libraries. Now, early versions of JSR 3.10 did allow that to be controlled by a strategy pattern, but ultimately it was decided that was a bit overkill, really, that one definition is quite sufficient, because we have other things called adjusters. So adjusters allow you to do more complicated adjustments. So if you did want a plus 3 months that went into, so 31st of January plus 1 month wasn't the end of February but was the start of March, you could write an adjuster that would do that. So here we've got some adjusters which are built in. On the temporal adjuster class, actually I think it's temporal adjusters, plural, there's a last day of month static method that is an adjuster. And once you statically import that, you get some really readable code. I want the date with the last day of the month, thank you very much. I want the date with next Tuesday. Or you can write your own, the next third Friday. There's actually one built in that does third Friday. So yeah, these that give you that desire to have code that actually is meaningful. Yeah, and yeah, you can write your own, test them up front, and do all sorts of things with adjusters. Ah, pretty sundials. If only we're still telling time with sundials, eh? So where the API uses the word time, it's generally referring to the time of day. So a time is what you see on your watch, what you see on a wall clock, except, of course, we're using the 24-hour clock, not the 12-hour clock. So days begin at midnight and end at midnight. The class is called local time. If you're wondering about that local word, by the way, it actually comes out of the ISO 8601 specification, which is the most widely referred to specification for dates and times. They use the term local. So this is storing hour, minute, second, and nanosecond, no time zone, no date. shop opening hours, time on an alarm clock. These are kind of things that you might use local time for. Again, we can create one. We can check to see whether the hour is greater than 12. Create one just using some values. Nice toString. Surprise, surprise, nice methods to add hours, subtract minutes, set the nanos, and we can truncate it. So if you want to knock off all the nanoseconds, knock off the milliseconds, knock off the seconds just to get it down to hours and minutes, there's a nice truncate method that allows you to do that. Local date time. Well, if we've got a local date, which is just a date, and we've got a local time, which is just a time, we can glue those two things together and get a local date time. So this is a date and time without any reference to a time zone. So you have to imagine an event that occurs at 10 a.m. in the morning on the 1st of November in London, or 10 a.m. in the morning on the 1st of November in Copenhagen. That's actually 1 hour apart, but you can still refer to it as being the 10 a.m. in the morning. It has all the same nice methods as we've just seen, so no great surprises on the API. There we go, there's an example. So yeah, a local date time that a flight takes off. Or not, if you're flying with the airline I flew this morning. Which was 40 minutes late, by the way. That's the Aztec stone, I believe. Because we have to talk about calendar systems. So what I said up front was the ISO calendar system, we treat that as being the default. That's the one you use every day. It's the one the vast majority of the world uses every day. We could call it the current civil calendar. What we do is we apply those rules for the entire timeline. So if you actually know history, the Gregorian calendar was introduced in 1580 or so, and before that we used the Julian calendar, and then before that we used the Roman calendar. But that all depends on where you were, because if you're in the UK, you didn't actually start using the Gregorian calendar until 17-something. So Europe and Britain were a day apart for a couple of centuries. That's not that unusual. Britain and Europe are falling apart at the moment. So yeah, by using the ISO calendar system for all time, we are not being historically accurate. But that's fine, because actually, when you're dealing with history, you generally generally need to be very aware of that historic change anyway. In other words, it's good to be up in your face as to what that actual date represents. So there are other calendar systems. They are deliberately treated as secondary. So we have the Hijra, which is the Islamic calendar system, Japanese, Mingguo, and Thai Buddhist. Those are the ones Oracle felt were the important ones to include in the JDK, and they did most of the work in terms of developing them. If you do want more, there's a library called 310 Extra, which you'll find on GitHub and in Maven Central, where there are a number of other calendar systems, mostly which are weird and wacky, artificially invented ones, but there are some real ones like the Coptic calendar system, and the Julian one is in there as well, plus the cutover that goes between the Julian and the Gregorian calendar. So, you know, and more are welcome. If you've got a calendar system you need to add, that's the place to add them. So calendar systems only affect dates and not times. So that if you actually go and look at the rules of calendar systems, they often say a day starts at sunrise or a day starts at sunset. Now, we do not model that at all in JSR 310. We always say days are from midnight to midnight, and it's up to you to sort out the dates. Chronology is the interface that represents this. You can find a chronology by name. You can use locales to identify them. So you've probably never seen a locale of the format -th-th-u-ca-Buddhist, but that is the official way in locale land under BCP 47 that you can represent Thailand, Thai language, you have the Unicode extension of a calendar of Buddhist. Okay? And these define everything in terms of an era, a month, and a day. So in most cases, you should use the ISO calendar system. We've chosen it as the primary calendar system. When would you use like the Japanese one? If you're writing a highly localized application, for example, for the Japanese government, you might need to use the Japanese calendar system. A globalized application where you're supposed to use whatever calendar system is appropriate for your user, well, we'll come to that in a minute. So there's a separate class for each calendar system, so you can represent the date specifically, but in most cases, just use local date. There are interfaces, chrono-local date, but again, generally, you would want to use local date and ignore these. Because all of this is really hard. When you go to another calendar system, you can't rely on it having the same number of months in a year. The Coptic calendar system has 13 months in a year, not 12. Some other calendar systems have variable number of months in a year, from 12 to 13 or 14. Sometimes you have a number of days in a month that changes from 30 days, and then there's one month with just 5 or 6 days. It's really easy to create bugs because you're applying your built-in knowledge of the standard calendar system that we all use to other calendar systems, and that knowledge often doesn't apply. So really, you need very detailed code reviews. Or, alternatively, you just use the ISO classes, and you convert to the other calendar systems in the UI. And that is by far the best way to deal with other calendar systems. It is a localization issue that should be kept extremely to the outside. After all, if you rent a library book for a month, the rule a month will almost certainly refer to a single calendar system, not whatever calendar system the user is trying to use. Otherwise, if they choose to use a calendar system which has got a 60-day month, they're going to get that library book for a lot longer than they would do with ISO. Time zones, yes, well, happy days time zones, Yes, the whole of France and Spain, they should all be using 0, not +1 on their time zones, if you look at the map there. So, the world is divided into time zones, and time and location is defined by political rules. These are politics. These are to do with people in power imposing their will on the people and enjoying imposing their will on the people. So Syria changed its time with 3 days' notice. You have an experiment in Western Australia. Some places change it every year. Egypt has 2 daylight savings periods, either side of Ramadan. This is quite common. What they're doing is they're defining a change in the offset. So in winter, France is 1 hour ahead of UTC. In the summer, it is 2 hours ahead. And then you define the days on which those cut over between the two things. That's the standard pattern for a rule. What the offset is in winter, what the offset is in summer, and when do they change between the two. You can get this data from more than one place. Now, by default, we use the time zone database, which is now hosted by IANA, and those are the IDs you probably recognize, like Europe/London or Europe/Copenhagen. But other people like Windows and IATA, that's the airline people, also produce their own time zone database. So there is a time zone for every airport, and that data is kept separately. The JDK class, time zone, represents the time zone offset and also figures out daylight savings. The word "and" in there suggests it's doing too many things. Should be split. So we separate this responsibility in JSR 310. You have a zone offset, that is the number of hours, minutes, and seconds away from Greenwich. Remember that Greenwich Observatory we saw earlier? That's the 0 point. We have zone rules that define what are the rules for switching between the offsets. So when does it change from 1 hour ahead to 2 hours ahead? What days of the year? And the zone ID is just the identifier that actually locates that rule. So you can create an offset, which is minus 0500. Go ahead.
Why was it plus 14 and not plus 12?
Right, okay, so the question is, why is the zone offset from plus 14 to minus 12? So when we had the millennium, some countries wanted to be the first place on the world to celebrate the millennium. So they deliberately moved themselves from one side of the international date line to the other side, and artificially created themselves new time zones. Yes. And some of them have moved back now. Time zones are political constructs done for the imposition of something on the populace. So, as you'll notice on this slide, I chose to define, I wanted to have some limits on what offset could be, so I decided 18 was probably a reasonable choice. So it gives a little bit of gap in case we have a second millennium where, you know, Hawaii decides to move to the other side of the date line. So the limits are minus 18 to plus 18, even though that's not actually the case. Yep, so that's how we create one. So the identifier is something like Europe/Paris. And when you compare two zone IDs, you're just comparing the identifier. You're just comparing that string. You're not comparing any rules or anything else.
So what will London be now?
So
London/London.
Europe/London. It's still Europe/London. But you can use, I think you can use GB as one of the old identifiers, but yeah. That's a continent, not a European Union, that one. We don't hate you, you know. Come out, you come out as well. If you join us, if you come out and Sweden comes out, you know, maybe we can all form a nice group together with Switzerland. Wouldn't that be nice? Sorry. Right, zone date time. So zone date time combines all the things we've talked about. It's a date, it's a time zone, and there's also an offset in there. Why do you need the offset? Because when you're getting those, when you're in autumn, you get the same hour repeated twice. And you need to know which of those two it is, and that's why you need the offset. Why do I write 1 hour ahead of GMT as opposed to 1 hour ahead of UTC? Most people use them fairly interchangeably these days. Some people will say there are subtle differences between the two. Others will say, in practical terms, it doesn't really matter. I use them fairly interchangeably, to be honest. No. GMT is Greenwich Mean Time. In summer, we use British Summer Time. So yeah, we use BST. So this is the closest equivalent to Gregorian calendar. So the concept that Gregorian calendar had in terms of containing all the data, that's the equivalent here. But it's got a much nicer two-string format. So use this one. So now we have to cover those gaps and overlaps. So we have a gap in spring where an hour disappears, and we have an overlap in autumn where the same hour occurs twice. Now early on, I had exceptions thrown if you got this wrong, but I concluded that basically the chance of you knowing that you got it wrong means too much checking up front. So what it chooses a sensible default. So if you try and create something in the middle of the gap, it will just create something after the gap. And if you try and create something in the middle of that overlap, where there's two things meaning the same, it'll choose the earlier one. So in practice, it always chooses summertime. Yeah. If you really care about this kind of stuff, there are ways of dealing with it. So we got some examples there. Yeah, so we're creating just before the daylight savings time ends. We're adding a day, which goes into the overlap period, and then later on we're changing the time zone. So the offset changes between the last two examples when we add an hour. So we have full access to the data. So if you want to know if a time is in a gap or an overlap, you can ask it. So we get the zone ID, we have our local date time, and we can say, you know, from the zone, get me the rules, and say, get me the transition for this local date time. And you'll get back a zone offset transition if it is a gap or an overlap, or null if it's not. I would have done an optional if I'd thought about it a bit more. This should return optional of zone offset transition. Because I was developing it during the Java 8 process, because I hadn't really learned when we should be using optional yet, it's not an optional, but it should be. So there's a offset date time class. So offset date time is a little bit like zone date time, but it doesn't have the time zone rules. It's the local date time just plus the offset. Now, when you send things across in XML, when you send things across on a network, this is the format you almost always use. You very rarely send the time zone itself across the network. You rarely send Europe/London across, or Europe/Copenhagen. You just send the date and the offset. And so offset date time and its friend offset time matches those formats. And these should be really useful for XML and database type environments where it matches exactly what that external system is doing. An atomic clock. So instants are it's storing the nanoseconds from 1970. And this is what closest equivalent to java.util.Date. Now, if you've ever looked at lots and lots of methods on it, they're all deprecated. They're all horrible. But fundamentally, java.util.Date is actually an instant, and that's how you should think about it. So mostly, you're just going to use this to compare is before and is after. We also have amounts of time, and these are not tied to the timeline. So you might want to say 6 years or 32.5 seconds. Yeah, these are useful things that you might want to express. So duration expresses a time-based amount. So if you want to express an amount of time measured in seconds, or nanoseconds, minutes, and hours, because they're all equivalently convertible, you use duration to do that. So you can say a duration of 6 hours, we can multiply that by 3, we can add on 30 minutes. And then we can take that duration and we can add it to a local date time. So that gives, that's quite nice. Period is the date-based equivalent. So this is an amount of years, months, and days. So we can say a period of 9 months. We can add 6 days to that and get a period of 9 months and 6 days. So that's just a standalone amount of time, quantity. And again, we can add that to a date.
And you can say, I have the same question that I started with. What if you say 9 months and 42 days? You would not do any calculation?
It's the same calculations before. It'll add 9 months and then it'll add 42 days. Yeah. So there are other classes. We have a year class, a year-month class, a month-day class. So year is useful if for things, primarily I would see that being useful for something where you like have a list of years, useful in a collection like that. Year-month, well, that's actually a credit card expiry date. Month-day, that's a Brazilian birthday, because they won't admit how old they are. Month is an enum, day of week is an enum, as you'd expect. And so that's your nice summary of all of these different classes. Yep.
Leap seconds.
We'll get to that.
Okay.
So local date, that's just the date. Local time is just the time. Combine those, you get local date time. Add on the offset for your offset date times. Add on the zone to get zone date times. And the instant is completely different. But obviously, there's a lot more types there. Previously you had Gregorian calendar, and that was it. So you've got to think about these things a bit more. You've got to choose your types a bit more carefully. By the way, if you've ever tried to use Gregorian calendar and set the time part to be midnight to represent just a date, there are places in the world that once a year have a daylight savings transition at midnight. And so your midnight won't exist. So your logic might not work in some places around the world if you're using Gregorian calendar with the time set to midnight. Oh, look, leap seconds. So the Earth is a real thing. And the length of an SI second is absolutely fixed. So a second is defined by movements in an atom, absolutely fixed, whereas a day varies and is observed by astronomers. So a day is not equal to 24 hours of 60 minutes of 60 seconds, i.e. a day is not equal to 86,400 seconds. They are typically slightly longer, although it varies all the time. So the purpose of UTC is to insert leap seconds to deal with this. So every 18 months or so, there's 1 extra second added in at midnight in London to handle this. Computers in general have never handled leap seconds well. And there's been loads of debates over the last 10 years by people in America and the Far East to try and get rid of leap seconds, which have basically come to nothing. That debate has kind of ended now. This matters a lot more to places like Tokyo, because while it might be at midnight in London, it's getting inserted in the middle of the working day in the Far East. So it can actually matter. They have to handle it a bit more. So Java counts milliseconds from 1970. But you see, there's a problem, because UTC was actually only defined in 1972. So it's quite hard to define what's the meaning of milliseconds from 1970 when the actual timescale didn't exist really then. The definition of milliseconds from 1970, it's based on the Unix definition, based on POSIX definitions, and it assumes 86,400 seconds a day. There's not really any solutions around leap seconds. You know, POSIX is a bit of a mess generally. So what we've done is invent a timescale. Happy days. So we basically say that midday is always midday and matches the civil time exactly. Other times are intended to match as best as possible, and a day will always have 86,400 subdivisions, which we call seconds. And therefore we can define what 1970 is. The net result is you can ignore leap seconds in most applications. In other words, there's a definition, you know, it allows those who really care about these things to go and look at it, but most of the time you can just imagine that leap seconds don't exist, and away you go. And this kind of matters because, in general, your clock on your computer won't get it right anyway, and clocks on computers do jump about a bit around leap seconds. In theory, the specification says we smear leap seconds. So over the last 1,000 seconds of the day, the leap second is meant to disappear. Yes?
I remember, I don't know, 12 years back, we had to calculate, add a week of Gregorian calendar and say how many milliseconds are there in a week. And that worked for most weeks, but not all weeks.
Mm-hmm.
So is there a suggestion saying have the largest major number or something like that when you add stuff? You shouldn't add in milliseconds, for example, if it's days you want to add, because days would compensate for the leap seconds.
So, I mean, in the Java.Time API, you just ignore leap seconds entirely. They are effectively swept under the carpet by careful spec stuff.
Yeah, but I ran into
You know, if you care about that kind of low-level accuracy, you're going to need to consider other options.
yeah, it was actually just a floor
Yeah.
on a linear. Well, it was an hour before or second.
Yeah, exactly. Yeah. They're really hard to get right because it's still not really possible to easily get at, you know, time sources that correctly supply leap seconds. I mean, Google, within all their servers, they set up their own time server that gets rid of the leap seconds. So within the entire, because they have their entire set of servers, they can basically set up their own clock, and all their servers see time without leap seconds. And you know, it's not a bad way to go about the problem. Integration stuff. So date calendar. So the SQL stuff does have some support for it. The SQL spec has been extended to mention these new types. There are no new methods, so you don't get result_set.getLocalDate. You have to use the getObject method, and they don't intend to add any local date specific methods. They intend to use getObject from now forward. It says they're not to be deprecated, but we'll see. As I say, they're sort of maybe changing their minds. Nothing in the new JSR 3.10 classes references the old classes. So if they are deprecated, it won't affect JSR 3.10 at all. Everything's based on this spec, ISO 8601. Yeah, it's the standard that you'll see all the other specifications based on. These types do map fairly well to concepts that you should see in databases, which is good. Some odds and ends, there we go. because we've got all these different types, you saw earlier local date, local time, year, month, it was necessary to find some way to join these types together. So this is where you'll see methods starting with @. So here I've got a year of 2013, and I call @month, and that will get back a year month object, and I call @day, and that will get back a local date object. So the prefix is used to join, is to make a smaller date time object into a bigger date time object. So date.@time 12:30 gets you a local date time, @offset 2 hours gets you an offset date time, or @start of day will get you, the zone date time at the start of the day, which will be midnight most days, but 1 a.m. if you've got a weird daylight savings time place. The current time is, of course, affected by what your time zone is. So earlier on, we saw methods like local date.now, and that uses the local time zone to determine what now is. But there are other similar requirements to access the stop time for test cases, to change time more slowly, move it into the future or the past. So there's a class called clock, and clock represents the current time. So instead of using local date.now with no arguments, you can use local date.now passing in a clock, where clock.system is the default clock that uses the current time zone and system to millis. But you could write a clock implementation that accessed NTP time servers, or that made it go slow, etc., etc. Now, in Java 8, those clocks will use system current time millis, so you'll get millisecond accuracy out of your clocks. In Java 9, they'll use a higher accuracy clock. So be careful when you're moving from Java 8 to Java 9, because you'll start to get back microseconds and potentially nanoseconds within your times when you query them. Be aware of that. Of course, the great thing about having a class that represents the clock is you can inject it. So if you want to do clocks properly, you would probably inject the clock into your system and never use local date.now with no arguments. There's a whole formatting and parsing API. So simple date format has lots of patterns, obviously, for defining the formats. There's an equivalent pattern API in JSR 3.10, main API being date time formatter. But you've got much more control over it. There's a formatter builder, just like there was in Joda-Time. And yeah, you've got much more ability to actually control the pattern and do weird things with it. Default things that are missing. So if you want to parse just the year and the month and default the day to be the 10th, you can do that.
Is the new formatting class thread safe?
The new formatting class is thread safe, yes. Yes. Hurrah. Oh, there we go. There's our format by pattern. So that YYYY, MMM, DD. So we can use the same pattern as we used before. The pattern is not identical. There are some subtle differences when you get out to the more unusual letters. But most of the letters are the same. So we can format it, so we can just do date.format, passing in the formatter. And we can parse using local date as well. So we can do local date.parse, passing in the formatter there. So it's the opposite way around. You don't have to call methods on the formatter. You can pass the formatter to the date class, which is quite nice. There's the builder. So we're creating the builder, we're appending the year value for 4 characters, a dash, month, short, a dash, day of month, 2. And there's a lot more power in that builder if you need it. Now abstracting, this is where things got complicated when we were developing it. The idea of JSR 3.10 is that you hold on to the concrete classes. So all those classes we've talked about up till now, like local date, local time, the concrete classes, those are what you should be referring to. Only low-level APIs like frameworks and interoperation code, that's the sort of stuff that might need this interface-based API. Temporal and temporal accessor allow you to get at date and time stuff, with temporal field and temporal unit being the fields and the unit parts. Duration and period both implement temporal amount. But yeah, in general, you won't need to use these interfaces. Calculate the number of days between two dates using java.util.Calendar. This is a question you will find many answers to on the internet, most of which are wrong. Alternatively, you could use JSR 310 and do days.between date 1 and date 2. Or period between date 1 and date 2. I mean, it's a lot easier because, for a start, there's no time part. Yeah, so you've only got to consider the days part, so you're going to get the right answer. You can extend it in lots of different ways. You can write your own date-time class, amount class, fields, units, calendar system. You do need to understand the Java doc. And to be honest, if you're adding something like that, have a look in the 310 extra project first. And if you're writing one, consider donating it to the 310 extra project, because if you think it's useful, maybe somebody else will. Aw, pretty. So there we go. In summary, it's a new date and time package for Java 8, java.time package. And we got the home page there, 310.org. There is a backport, and there are lots of extras available there as well. I hope that's helpful to you, and I hope you enjoy using java.time. Thank you. Any more questions?
How did you come about working on this? Who financed your work?
How did I come to work on this? So back in 2000, I was writing a library effectively called Joda-Beans, and that library needed a way to convert dates to and from a string, for which I wrote a little library, which grew to be a bigger library, which grew to be a bigger library, until eventually I developed Joda-Time and dropped Joda-Beans. Now, as you may, if you heard my talk earlier, I've reinvented Joda-Beans, so it's actually much better than it was back in 2000. So Joda-Beans does now exist again from 2010 onwards. So that's how I did the Joda-Time stuff. That was all in my free time when I was single. Over time, it became apparent that people wanted it into JDK, so I got persuaded to open a JSR. Somebody else helped me open it, and then it kind of just took forever and ever to get developed. I got some financial support from Oracle. I got some financial support from my employer, OpenGamma. Basically, when I joined OpenGamma, that provided me with some time during the day to actually work on it and get it finished. But it just took a very long time to do, and there were times when I would just give up and not be interested in it because it's a complicated domain to get down to a reasonable size API. You could make this API a lot smaller, but you would be compromising on some of those goals, particularly around extensibility. So if you want to have those goals in Java, which isn't, if you ever Google the expression problem, if you want to understand part of what you face, it's a tricky problem. We got there in the end.
Overlap between Java.Time and Joda-Time.
What's the overlap between Java.Time and Joda-Time? Well,
Percentage.
I mean, in terms of the API, they're probably 70 to 80% of the things are covered. So Joda-Time has some extra concepts, and Java.Time has other extra concepts. People think intervals is perhaps the biggest thing, and period formatting. Those are the two big things missing from that are in Joda-Time and not in Java.Time. Intervals are available in 310 extra, or you can use the Guava range class, which is equivalent. Period formatting, maybe that'll get added in a future JDK. I don't know. It's quite. There are some subtleties around the human language element of that, so it's quite tricky.
JDK doesn't support this yet, right? We still need to merge it into the old JDK.
Yeah, does JPA support it? I believe there hasn't been a version of Java Enterprise Edition out since Java 8 was released. Therefore, yes, I guess it doesn't support it. I guess individual vendors do. I have to say I don't use much Java EE code or the JPA code at all, so I can't answer it specifically. But yes, I believe you're accurate that it's not supported yet. But I'm fairly sure Hibernate has some plug-in points for it.
You write your own type.
Oh, yeah.
Yeah.
To write all types.
Yeah. Okay.
What does 310 stand for?
What does 310 stand for? So the JSR is called JSR 310, 310. Therefore, the library is called 310. I know. Shucks.
What you read out the number is actually how far back it was the ticket was.
Yeah, exactly. It's an old one when you look at the latest JSRs that are out there.
Okay.
Cool.
Thank you, Stephen.
Cheers.